Well, hello there. I'm gonna show you guys how to solve some linear equations real quickly as our first section I want you to do on IXL. Let's go through a couple tips here with you. And when we simplify math, when we do what it says, we follow PEMDAS. Lets us know what order of operations we're solving. We undo PEMDAS, and so we always look for subtraction, addition first, division, multiplication second, then getting rid of exponents, then working inside the parentheses. But before we solve, we do need to make sure we've simplified things. So doing things like combining like terms or distribution before we try to solve. So get the each side as simple as possible, then try to solve it. So I notice here on the left side of my equation, I have these two constant terms. So I'm going to go ahead and combine those. Remember, when you're combining, you just do what it says. So that's negative 20 minus 15. So that's negative 35 plus 12x equals 20 plus 7x. And now I want to start moving stuff across the equal sign. So now I need to start worrying about doing the opposite of what it says. And first thing I want to do is gather my x's on the one side. So I'm going to take the smaller x term and move it to the left side. And since the x's are going to come to the left in this case, I'm going to take the numbers and move them to the right. So I'm going to add 35 to both sides. So on the left side, those cancel, those cancel. So left side, 12x minus 7x is 5x. And on the right side, 20 plus 35 is 55. Now that I don't need subtraction addition to do, but now I have some division and multiplication to do, because the 5 is multiplying the x, so I'm going to divide by 5. And so x would be 11. There's one example of a problem that would be typical of what you're being asked to do. And another one would be, let's see here. Might see something with some distribution in it. So maybe something like negative 4 times 8j minus 12 equals 4 times negative 6 minus 17j. So I want to go and distribute here on each side. So negative 4 times 8 is negative 32 j's. Negative 4 times 12 would be positive 48. And then distributing on the right side. 4 times negative 6 would be negative 24. 4 times 17 would be 40. 28, 68 j's. So I'm all done distribution. Both sides are as simple as I can make them. Now I want to look at my variables and get them on the same side. So negative 68 is actually smaller than negative 32. So I'm going to add 68 j's to both sides. So I do this, I'm always moving the smaller one to help keep the variable terms positive. Just because I think it's easier. But then since the j's are moving to the left again, our numbers are going to move to the right. So I'm going to take that 48 and kick it to the other side. So minus 48. So that cancels, that cancels. So I get negative 32 plus 68, which is 36 j's. And negative 24 and negative 48. So both negatives, add them to 72. So negative 72. And divide by 36 to get j by itself. And so j would equal negative 2. Typical problems you might see getting up to the level I want you to get to. So go ahead and try those and come back when you're done so you can look at the second section. So in this section, we're going to be solving absolute value equations. So one kind of typical example might be something, I'm going to start with that easy one to kind of get you into it, understand what you need to do. So something like 5 equals the absolute value of 5b. And you will notice that they ask you to write your answers as integers or improper fractions in the simplest form, and all these, we'll talk about that. So remember what absolute value does is that it makes the whatever is inside positive. So if I say like the absolute value of 7, that's 7. But the absolute value of -7 is also 7. It's the distance that number is from 0. So if I say something like the absolute value of x is 3, well, what that means is that x could either be 3, because the absolute value of 3 equals 3, or x could be -3, because the absolute value of -3 is also 3. So what are the inputs that give me that particular output? So I could input 3, or I could input -3, and I get the same output. So what we see here is that once we get the absolute value isolated, so as long as there's nothing on the outside of it, we're actually going to end up having to split the equation into 2. And we saw this earlier in Unit 3, that we had to do that for a particular solving. And then we solve, when we do that splitting, so look, I went from here, there's bars, absolute value bars are here. When I split, that's how I get rid of the bars. So how do I unabsolute value? Okay, unabsolute value by splitting the equation into 2 things. And we either should have those solved at that point, or like very close to being solved. So I have 5 equals the absolute value of 5b. So if I want to, get b by itself, I have to get rid of those bars first. And so I'm going to split this problem into 2 problems. So notice that the x didn't change signs. X was x both times. What was inside the absolute value bars didn't change. It was what was over here is what changed. The 3 went what 3 once, and the 3 was -3 once. So what's going to be in here is not going to change. This is the part that's going to change. So one time it stays positive, so 5 equals, and then the part inside the bars does not change, but the bars go away. And then the second time, that 5 is going to turn into negative equals, and that 5b doesn't change. So make sure you get rid of the bars here. You have both possible values. So we're going to get rid of those 5s. 5 by 5, divided by 5. So over here, b could be 1. Over here, divide by 5, divide by 5. B could also be -1. Okay. So something a little bit more complex. Now you kind of know the only trick to these, okay, is if we had something, let me get a problem here real quick. So example 2, we have something like the absolute value of x plus, let's try something different here. I'll try x plus 7 plus 5 equals 22. So before we can split this, we have to get everything on the outside to go away. So look at the outside of the bars, notice that there's a 5 there. So I'm going to go ahead and get rid of that 5. It's definitely a mistake if you split it too soon. X plus 7 equals 22, so 22 minus 5 is 17. Now that the outside of the bars are clear, to get rid of the bars, want to split the problem. So remember, one time inside bar of the bars never changes, so x plus 7, that doesn't change. And the first time I just write it the same way I had it, so 17. And then the second time, inside doesn't change, x plus 7. But now I'm going to write negative 17. And then, of course, from there, we just want to subtract 7, subtract 7, subtract 7, subtract 7. So x could be 10, or x could be negative 24. Those are my two possible answers. They're also going to ask you some questions like, how many possible answers are there to these problems? And so basically what they're getting at is if we have something like the absolute value of x equals 5, there are two possible answers to that. X could be 5 or x could be negative 5, because those two numbers are both 5 away from 0. Well, we could also just have one answer, but what that would be is that if the absolute value of x was equal to 0, because there's only one number that's 0 away from 0, that's 0. So that has one solution. And there are some of these that also have no solutions. So the absolute value of, so what would absolute value never be able to equal to? Like something like negative 5. There are no numbers that are negative 5 away from 0, because distance is always positive. And so this problem would have 0 solutions or no solutions. So if you're doing any of those problems where it asks you how many solutions are, that's what it means. So if what ends up on the part without the bars is 0, there's only one answer. Yeah, if you have to move anything first, like we did here. If this had been a 5, so I'd take 5 minus 5, then I'd have x plus 7 equals 0, I would only get one answer out of that. If the number that's on the part without the bars is a positive number, then there will be two solutions, like this. And if the number that's on the side without the bars is negative, there'll be no solutions. Okay. So why don't you guys go ahead and try the solving the absolute value problems, and come back to me when you're ready for the quadratics. All right, so the last one is solving quadratic equations. We did this a bit in Unit 3. And kind of like with the absolute values, there's just a little bit of a trick to it, but we've been talking about this in class. And so it maybe shouldn't be as a big mystery, but there are definitely ways to do this, more than one way to do this, but I'm going to show you the easier way by far, and definitely not the way that photo math would show you. So I don't know why you'd even be trying to use that. First example, something like z squared minus 2 equals 34. Okay. Remember, we're just using SAD map here. So I want to get z by itself. So I want to undo any subtraction addition first, undo any division multiplication second, undo any exponents and anything inside parentheses. Of course, I don't have parentheses here, but so I see that adding and subtracting that 2. So I want to add 2 to both sides. So I get z squared equals 36. And we get rid of squares by square rooting. And so, of course, square rooting means to find a number that multiplies itself to give us 36. And so not only is 6 times 6 36, but negative 6 times negative 6 is also 36. So we also have kind of a splitting idea with square rooting. Okay, so both the absolute value and the quadratic equations will often have two answers. Can get a little bit more difficult if we say something like I'll say x plus 5 squared plus 12 equals 61. So I want to look on the outside of the parentheses for any subtraction or addition to do. So I got subtracting 12 to do. So I get x plus 5 squared equals 49. And then I'll look on the outside of the parentheses for anything to do. So I got a division multiplication to do, but I do have an exponent to get rid of on the outside. So I'm going to square root both sides. And so on the left side, that just cancels. We get x plus 5. But on the right side, that's square root of 49. So again, what number times itself is 49? Well, 7 times 7 is 49. But also, negative 7 times negative 7 is 49. So this is that splitting idea again. Writing two equations, and then continuing to solve those two equations. So minus 5, minus 5, minus 5, minus 5. So we find out that x could be 2, or x could be negative 12. And you can go back and check that, like 2 plus 5 is 7, 7 squared is 49, 49 plus 12 is 61. Well, negative 12 plus 5 is negative 7. Negative 7 times negative 7 is 49. 49 plus 12 is 61. So we can see that both answers do work. Yeah. They may also ask you questions about like how many answers there are. So again, we talked about this a little bit again in Unit 3. If you have something like x squared equals 16, so if that value on the right side there is positive, that could be x could be 4 or x could be negative 4. If x squared equals 0, then there's only one number that's times itself. That's 0, so that's 0. So there's only one answer there. And then if you had x squared equals negative 2 or whatever, negative 16, there's no number times itself that is negative 16, so there's no solutions here. So it's doing one of those, how many answers there are questions, and that's what you're looking for to judge is if this side is positive, there'll be 2. If this side is 0, there'll be 1. And if this side is negative, there'll be none. So, all right, hopefully that went okay, and you did well at solving all those equations. I'll see you guys on Tuesday.